Sir, may I audible? Good evening to all. Today is the second day of the 1 week activity on building sustainable infrastructure for urban and social resilient challenges and future pathways. In this session, the topic is sustainable urban planning. Today's expert, today's expert, engineer Rohit Gandhi. Rohit sir, may I audible? Rohit sir. Rohit sir is the head of the project control, Recon India Limited. Core competency for project planning and scheduling, project control and cost management, construction management, progress monitoring and reporting, stakeholder coordination, team leadership and process implementation. His professional experience, seasoned civil engineering professionals with over 10 years of industry experience in construction planning, execution, and project controls. Currently, he is heading the project control function at Recon India with proven expertise in managing complex projects, implementing structure control systems, and delivering projects within times and budgets. Passionate about sharing industry knowledge and practical insights with aspiring engineering professionals. He is well experienced for leading the project control function across multi-construction projects Then also the establishing control system ensure adherence to project timelines, budgets, and quality benchmarks, supporting senior management with data-driven insights for effective decision making. Rohit sir, over to you.
Rohit sir, hello.
Hello, Rohit sir. Rohit sir. Rohit sir, may I have you?
Yes, yes, I can hear you. Sir, can you hear me, Bobres?
Yes, continue to me. Continue.
Yes, you can hear me?
Yes.
Yes, sir. Yes.
Yeah, yeah, yes. Yes, so a very good evening to all. As sir gave my introduction, myself Rohit Ghadge, and I'm working in project controls. So my entire work experience is in project planning, coordination, scheduling. I'm not basically in like doing the physical, like the architect do that type of planning. I'm not involved in it, but this a particular topic always excites me, as this is our like day-to-day function which affects each and every one of us. So like just one question that each one of us are like related to. I would like to ask, like whenever we are traveling, or whenever we are like commuting for our each and everyday travel, that time each one of us are obviously facing the traffic issues. Everywhere there is like solid waste, or like unhygienic environment is always there. So this topic particularly like circles around the particular thing of making the city development or urban development sustainable. We will get started with the topic. I'll just start sharing my screen. Can you all see my screen?
Yes,
Yes,
sir.
sir. Yes, sir.
Yeah, yes. So our today's topic for discussion is sustainable urban planning. Uh, it is when we say like sustainable urban planning, it is not just about cities, roads, or buildings. It is about how people will live for the upcoming next 100 years. So whenever we are like planning or constructing any city, it is not for like few years. Like it is not 5, 10 years of thing that we develop a city. It will last for upcoming 100 years, and the people will be living or using each and every infrastructure that is built, and it will be for the futuristic thing. So every planning should be done keeping that in mind. Then every decision as we take as a planners, engineers, or architect or policymakers has a long-term impact. So that should be kept in mind. So a road alignment today decides a congestion for 40 years, and a drainage mistake today decides flooding for generations. So, as I asked like a question about traffic congestion or water shortage or flooding in your city, like I guess each one of us has like physically or personally experienced that thing, not just seeing it in like news or all. We have personally like experienced this situations. So that thing comes like that thing brings us the question about why sustainable urban planning. So, just to give some facts, I'll explain few things about the urban development. So, cities, particularly urban areas, occupy less than 3% of Earth's land. So, when I'm saying it is less than 3% of Earth's land, so about the geographical areas, they are very small, but yet they consume 78% of global energy, and they produce 60% of these greenhouse gases. So this is what means is the cities are small in size, but they have a massive impact on environment. By 2050, 68% of world population will live in city. This is the projection. So just like imagine the number of 68% of entire world's population will be living in cities. So India's cities already contribute to 65 more than 65% of GDP, but they also consume more of our resources.
Hello. Hello. Hi.
Hello. So poor planning creates congestion, pollution, and flooding. So sustainable planning. So on the other side, sustainable planning ensures long-term livability and equity. Looking at the urban growth that India has, so urban population, if we look at the history, so in 1951, only 17% of the people were living in urban areas. So by 2021, it rose to 35%, and in the upcoming years, the number is projected as 45%. So by 2035, we are expecting 45% of the entire national population to be living in cities. That has a rate of 30 people migrating every minute. With that, like high speed, people are migrating from rural areas to urban. So about when we are saying this at this speed, when people are migrating, we need 700 to 900 million square meter of commercial and residential development to be done. Then 2.5 million square meter of roads to be developed, and 7,000 kilometer of metro rail. So like we can see around us, like all this construction is ongoing, but this is a huge requirement that demands the future urban population. So when we are saying this is not future planning, it is already happening. So as I said, like there are 30 people migrating at like every minute they are migrating to cities. So when we are saying like these many people are migrating to cities, and like that adds up to a load on the infrastructure that is there in the urban areas. So when growth is not planned, cities start to fail their citizens. So first major problem that we face is traffic congestion. So when we are like comparing the speed of travel, so average speed in metro cities is just 15 to 18 kilometers per hour. So we can not to go like to compare any metro cities as well. Even we see a city like Pune, even so in inside the city in heavy traffic areas, when we want to travel like 15 to 18 kilometers, it needs more than an hour. So that is a really thing to worry, and we need to think about that when we are doing up like planning for urban areas. So which also like results in fuel loss as well. So 30 to 40% of fuel wastage happens just in the congestion. So this traffic not only takes our time, but also cost us the fuel wastage. The next problem we face is about water stress. So, like cities like Bangalore and Chennai. So, like when we say like these cities, sometimes we see these cities are flooded, but due to, in the time of summers, they face the water scarcity. So, what is the reason behind that? So that happens because of the losses happened due to the leakage. So for that is the number itself is a huge 40 to 50% of water like lose we lose in due to leakage. If we manage that properly, there won't be any issue about the water scarcity. The next problem we face is about air pollution. So with all this urbanization, development, then traffic, everything adds to air pollution. So each one of us are like recently must be seeing this data on news or on our social platforms as well, that we see like people are worried about air quality index. So this is the problem that we will be facing if we do not plan for that, for the urban development. So that will definitely be like a huge problem that we need to take care. But that cannot be taken care once the problem is like beyond our control. It should be handled, or it should be thought of at the time of planning itself. Then the next problem is about flooding. So flooding and informal housing. So this particular problem happens when we do not do proper planning. So due to our requirements, we are building like concrete roads. There are pavements which are impervious. All these things are good for our vehicular movement and other stability point of view. They might be good, but when it comes to a flooding problem, so we do not, if we do not provide uh, any way to for the runoff water, there will be issues of flooding. So these are the particular challenges that urban cities are currently facing, and which should be handled at the time of planning itself. So these problems are not actually the natural disasters; they are planning failures. So with understanding all this futuristic demand and growth that we are expecting, and the current challenges that these cities are facing, which makes us think about the sustainable urban planning. So what is a sustainable urban planning? So urban planning is not one solution; it is an integrated system, we can say. So to define it, we can say it is integrated land use, transport, environment, infrastructure, and social equity. So today's needs are met without harming the future generations. This with this we can define what sustainable urban planning is. And when we are like doing this planning, it is done with keeping a 30 to 50 years of horizon. So we need to think about the upcoming expansion and the load that will be coming on the cities. So we have to think about the resource efficiency, the climate resilience. It cannot be like we are just building our cities to meet our development demand, or to provide our facilities, provide us the facilities. It should be like climate resilience as well. As we just understood about, if we do not build pervious pavements, there will be issues about flooding. So these things should be kept in mind. And then the when we are doing this development and balancing the environment, so this is what we call it focus on quality of life and inclusivity. Can someone mute? There is a noise. Yeah, thank you. Yeah. So when we are thinking about urban development, these are the three major pillars of sustainable urban development. So UN defines it simply as make cities intensive, safe, resilient, and sustainable. So for these three pillars, we have to think about environment. So environment is we have to think about maintaining green cover, flood mitigation, and pollution reduction as well. Then the second point is about economic. So when we are building the infrastructure, it should be efficient, lower, the operation cost should be lower, and it should be inclusive or affordable to everyone that is living in that city. The third pillar is social. So it should have equitable access. It should not be like some people or limited people have the access. It should be accessible to each and every individual or population that is living in that city. Then vocability, then public health. All these things should be kept in mind when we are doing the urban development. And it should have a long-term resilience. when we are doing the development. If and when we are like understanding all these three pillars, we have to think or understand that if one pillar is weak, the city becomes fragile. So all these things, three parameters or pillars, are equally important when we are doing the planning. So next point, we will come to land use planning. So land use planning decides how far we travel every day. So with this concept, just to give you an understanding about when we are understanding this point, when we have our house at one location, our workplace is at another location, if schools are not nearby the residential areas, so there will be obviously the load coming on the transportation system. For each and every need of ours, we have to travel far distance every day. So that should be that should be avoided when we are doing the planning. This is what the land use planning explains. So it should be mixed use development, and it should avoid far transits. If homes, offices, schools, and markets are far apart, then city obviously forces people to drive more. So that should be kept in mind when we are doing the planning, and it should be avoided. Then there should be open spaces for natural drainage corridors, then enhance accessibility for reducing the travel demands. Then we will come to technical components, technical planning components. So first point that we just understood is about land use planning. Land use planning is explains us about when we are doing planning for city, it should be focused on having all the like daily required locations at accessible distance. It should not be more than like 500 to 800 meters far. That is what the point explains us about land use planning. Then we will come to a point about water sensitive urban design. In water sensitive urban design, we can say traditionally cities treat rainwater as a problem, but sustainable cities treat it as a resources. When we receive the rainwater, we should have a proper planning that it will definitely prove us as a resource. For that, we need to focus on rainwater harvesting, permeable pavements, biowells, and urban lake and wetlands. This will help us to manage the surface runoff that we face during the raining season, and without like that water being wastage, or even it should not cause us a problem of flooding. It will be percolating into the ground, and it will recharge the groundwater storage as well, so that we can like later on use as a groundwater, and it will be like beneficial rather than being a problem. So for as an example, we can look at Chennai floods and water shortage exists simultaneously, because like the problem is about managing, not about water scarcity. We are not properly managing the water. That's why we face floods and water shortage as well. This majorly happens in the areas of coastal region like Chennai, or this can be avoided, or it can be utilized as a resource if we do a proper planning. Then we will come to sustainable transportation planning. So in transportation planning is actually land use planning. So we should have the hierarchy like this. We should have a priority to public transport first. Then we should use walking or cycling. We should avoid a motorized transport firstly, and then if it is not there, then the last priority should be private vehicles. So like most of the time it is happening like reverse. Everyone is like preferring the private vehicles, obviously because of the uh, like advantage or the comfort they provide, or the accessibility to each and everyone. But if we work on the infrastructure and make it like accessible and easy for everyone to use and reduce the travel time, it will definitely be useful, and people will definitely prefer to use public transport if we work on that on the planning stage itself. So, like for improving that transportation, we can use approaches such as metros, uh, BRTS, like EV infrastructure can be developed. Then we can work on the parking management. Like most of the places, we face the problem of having the parking shortage. So when we are traveling to a crowded space, there is this problem of parking space. So because of that, many problem we face many problems. So that should be also thought of when we are doing the planning. So, like definitely, when we are thinking about solving the traffic problem, we have to think like you cannot solve a traffic by building more roads. It is it is not just about number of roads or length that we are increasing. We we need to think about managing the parking and other infrastructure as well. Then the next point is about sustainable drainage system. Flooding, when we are thinking about flooding, so flooding happens when cities replace soil with concrete. Obviously, this is what happening in most of the urban areas. So when we are developing a city, like nobody wants the dust to be there. Like they want everything clean, and that comes with a paved pavements which are like concrete or pavers are installed. So with like reducing that soil, we are creating a problem of drainage. So that we need to think about, and we need to shift to some like at least semi-pervious roads or pavements, so that we can avoid the problem of flooding. So there should be a way to the rainwater to percolate or to flow somewhere. Otherwise, it will definitely flood at one place and will create a problem of flooding. So for that, some some remedies that we can use are green roofs. Then there can be retention pots. This is definitely possible when we are like doing the planning at the early stage, and with the like government's initiative, it can be definitely done that we can build detention ponds. Then there can be natural stormwater channels. Otherwise, also we can do GIS flood modeling as well. So these are the things that can help us to avoid the flooding situation. For example, we can look at Surat. So Surat reduced the flood response time by over 50% by using the GIS planning. So they have installed particular alarm system that warns them 5 days before if there is like water level rise. So accordingly, the actions are taken, and the population is warned about the upcoming disaster or any challenges that they might face. Then we will come to a next point about energy efficient urban design. So energy efficiency starts at the planning stage, not at the meter. Like when we start using, we cannot think about it at that stage. You need to think about when we are doing the planning. So at the planning, we should think about how we are orienting the building. We should have that proper direction about ventilation, then urban shading, district cooling, and solar rooftops. These are the things that we can think about. Like solar is a concept that most of the people are understanding and now implementing. So that will definitely prove helpful for each and everyone to have energy efficient environment. Then next point is about solid waste and circular economy. So waste is definitely like there will be when the population is there, when we are using uh, any like food, when we are consuming food or using any other material, so there will be definitely generation of waste. But waste becomes a problem when there is poor segregation. So with poor segregation, then the decomposition or uh, the final treatment that we want to do with the waste becomes difficult or sometimes impossible. So with that, we need to focus on the segregation of the waste that is being generated. So that for that we need to focus on segregation at source. When wherever the waste is being generated, at that stage it is the most easiest to segregate. Then waste to energy, when we are segregating, then there are definitely many ways to have any fuel related bioproduct when we do a treatment on waste products. Then the point about construction and demolition waste reuse. So this is the most important point when we think from civil engineers point of view. So when we are having the construction waste, there is in talking about the quantity, it is a huge waste that is being generated. So with that, we need to think about how we can reuse that, reuse the demolition waste in, like, it can be used in the pavements or any in the like new construction as well. At the when we are doing any just filling concrete in that things, it can be used. So with this initiatives, we can reduce the solid waste that is generated, and decentralized processing can be there. Like if we are doing a processing at one point, like there is a question, or there is a uh, there is a problem that the city or urban areas face about is like dumping stations. So it can be like, it cannot be centralized. So we can do a decentralized processing, and we can have it like at multiple places, so to avoid the load on one system itself. So, for example, we can look at Indore. So, Indore is like for the past few years, it has been consecutively, it is scoring as the like cleanest city. So, they have this system of like they are achieving this cleanliness because they are doing this 1200 of 1200 tons of waste from landfills because of system design. They are diverting this much of waste because of their proper segregation that they do at the source itself. So when we are thinking, or when we are discussing all these action points or initiatives that needs to be done, so like obviously this needs intervention or action from the government or the system itself. So when we say, like, there are definitely systems, or there are definitely some initiatives being taken by government. It is not like the India is not lacking policy, but it needs better execution. That is what we can say about this. So there are many policies that are being initiated or implemented by the government. uh, few are listed here. So but the final output we can see only when there will be active participation by each and every individual. So there are listed here are three popular or currently implemented policies. One is smart city mission, then second one is Amrut, and third one is Swachh Bharat. So each one of it is focused on like different initiatives. Like smart city mission focuses on developing like multiple cities in the country, so that there will be there will be distribution on loads on the particular cities. There should not be like only the metro cities are having the development, and they are getting like overpopulated, and the load on that
Starting the
infrastructure is
Sakariyanale,
growing beyond their control. So
Sakariyanale.
then there is
तू
Amrut.
रिश्ते का
So
कर लेगा तू रिश्ते का
Amrut
है ना
policy focuses on
तू रिश्ते का है का
doing the water
काही
coverage,
से नहीं ना
then
तुमच्या
treating
पलीकडे
the
राहणार तुझ्या
wastewater, solid waste treatment as well. So
हो
then there is Swachh Bharat. So Swachh Bharat is about garbage-free cities. Then we have been seeing this open defecation free scheme that is being implemented like for so many years. There is definitely improvement. We can see like there is a lot of change, and each and every, like most of the people have like toilets at home now. But this needs to like 100% achieved. Like there are still some rural areas that are not using the toilets. So these are the few schemes that I have highlighted here, and there are some guidelines that are like there in the government system. Also for some the pillars that we previously understood about uh, green system, so we can work on like rooftop gardens, then park and open spaces, green roofs and rainwater systems. So these are the few things that can be implemented as a good urban design practice. Let's come to few cases that are being implemented here in India. Like I have like with intentionally not mentioned any of the foreign examples here because like we see like there is obviously every time an argument that like India is different, or like there might be other environmental challenges, or like we will need more time to train or to educate our people. So just not look at any other country, we will see few examples from our country itself. So one case is from Ahmedabad. So in Ahmedabad they are like they are running a very good system about BRTS. In Pune also they had this trial, but some of the places it is not working that good. So that needs to be thought of, like why it is working there and why it is not working here. So about this, like when we are looking at the scheme of BRTS in Ahmedabad, so they have built this around 100 kilometers of Janmarga, and which has enabled them to have a model shift of 20 to 25% from private vehicles and to the bus transport, and which has helped them reduce the CO2 emission by 30 to 35%. So that is a huge number and impact that they are seeing with this with practice that is being implemented, and that is definitely being proving as a proving helpful or showing the results for them. There are a few things like riverfront development. We can see this same initiative being implemented here in Pune district as well. So that is a good thing about uh, riverfront development. Like in city like Pune, there are a few like few rivers like Mura and Mutha. So if like we can see in some of the urban areas, at some places we like really cannot identify them as a river, looking at their current situation. So just not to keep the situation for future, and to maintain that riverfront as for the upcoming generation as well. We should work on this redevelopment. Then there is one concept about TOD. So TOD is about transit oriented development. So in that thing they have worked on it. So this particular point focuses on having a proper development nearby the transport. So there should be like maximum development happening when we have a access road. So if we do not have a development nearby the road, there should the people every day have to travel from their residence to that particular main access road, and then their travel will start. So this particular thing increases the load and also causes inconvenience to the commuters which are like using that facility every day. So this should be thought of. Then, as we discussed about, so they achieved this 20 to 30% of public transport reduction, and also saw reduction in CO2 emission. So these are the achievements they have uh, they have achieved through this BRTS implementation. And there are some other cities as well, like Indore. So just now, as we discussed, it is the top clean city in India. So they have achieved this 100% door-to-door waste collection. So this is and after that they have achieved more than 80% of waste segregation. So this is what the thing they are following or implementing, and which is helping them achieve this clean city title every year. So when we segregate the waste, we have a resource, not as a waste product. So with that segregation, we can definitely work on that, do processing, and have a like usable product out of that byproduct that can be developed when we do a proper segregation of that. Then we see in Surat, just as we discussed, there is a early warning system they have installed for flood response, so which gives them a warning 5 days before whenever there is a rise in the water levels. So it is about the GIS flood resilience planning. So this is helping them to keep the system and people prepared for upcoming any flood situation. Then as like from many years we have also studied in books as well, so about the Chandigarh pattern. So they have, that is a pre-planned city. So in that, so they did this master plan about the road network. So they have this grid pattern, and which is helping them uh, to have access to each and every need place that they have to commute every day, like schools, parks, and shops within 10 minutes. So that helps them the daily travel demand, which is like significant reduction, and which is definitely a convenience for every commuter that is using this system. Then Delhi, so like even though like Delhi is facing major problems about pollution and traffic congestion. Still, after the construction of metro network, so they worked on the extensive metro development, and which is like 390 more than 390 kilometers network that has been developed and being operated. So it is transporting around 6 million passengers per day, and that is helping to reduce more than 6 lakh tons of CO2 per year, and also saving 1.5 million vehicle trips per day. So this is like about both convenience to the commuters and also the environment impact. So when we are looking at these big numbers about like CO2 emission and also the vehicle trips, like when we are saying like 1.5 million vehicle trips, so that is both ways definitely useful. Like people are having comfortable travels using the metros. They do not have to like physically drive, and that avoids that stress as well. Also saves money on the fuel expenses. These are the benefits that they are getting. But definitely there is a lot to be done in the city like Delhi to achieve more and more comfort, or to have a better execution of urban planning. Then we see the city. Then we will see a city which we most of us are living. So Pune. So in Pune there are cycling lanes, metro integration, and non-motor trans, transport corridors are expected to shift 15 to 20%. So in Pune, we are currently seeing this development being done. So it is not operational currently, but with the time, when this all will be available to us, this will definitely help and will reduce the load on the system, and also will give us some relief and comfort when all this gets developed. Then next point is about waste and water management. So there are, when we think about the solid waste management, then about the solid waste, there are like, if we look at the statistics, there is around 1.5 lakh of 1.5 lakh tons per day being generated in urban areas. So which has like more than 80% of collection coverage. Uh, so and like most of the problem arises when we are not doing the segregation. and not doing the composting or recycling. So just now we understood the example of Indore, and if that is being practiced in most of the cities, that will definitely help and will prove helpful. And then there will be like very less load on the system as well, and we will be able to see the clean cities. Then the second problem is about sewage and wastewater. So around like 80% of urban wastewater is untreated. So that's why like the initiative like Amrut 2.0 aims at like 100% sewerage treatment and having STP capacities expansion. So with this, whenever is untreated water is like disposed in any natural water source or dumped directly underground, so that creates a like a huge problem of having this soil contamination or as well the water pollution. So to avoid that, if we treat the waste at the source or do a treatment on it before disposing, that will reduce the risk of pollution and will prove helpful. Then point is about rainwater harvesting and groundwater recharge. So, like just now, we understood like some cities are like Chennai and Bangalore. They have good rainfall intensity, but still they face some water scarcity problem. So for that, we need to work on the groundwater recharge. So that water we can use in the summer days or dry period when the water is not available. So as we understood, like around 40 to 50% of urban water is lost due to the surface runoff. So that we can mitigate through the rooftop rainwater harvesting system, and that we can add to recharging the groundwater storage. Then the next problem is about flood and stormwater management. So for this, like we have to work on this GIS, this drainage mapping or stormwater network, just like the system being installed in Surat. So like we can do like other measures as well. But if we have like early warning system, so we will be prepared for the upcoming disasters, and will be like we will be successful with facing those, and will reduce the impact with early preparation. Then there is circular and green approach. So when we are like composting wet waste or recycling wastewater for irrigation and integrating blue green infrastructure, so which is having like lakes or water bodies, wet areas, and also having gardens or green green drainage systems or tree plantations at public places, that will definitely prove helpful to improve the like as the air quality as well, and also to maintain the temperature of the surroundings. Like with this planning, we can achieve this both like air pollution will reduce, and also the we can have like cooler environments. This both benefits we can achieve. So this is about a wastewater management, that waste and water management that we can practice and try to achieve like more and more benefit of this. Like just now we understood about the previous condition that was there, or the current situation, and what we are expecting for future. So when we are uh, saying the future cities will be data driven and climate resilient, for that like there will be definitely actions or planning that needs to be done at early stage to have like a better future or better environment for the upcoming generation at least. So when we say like decarbonization with the massive concrete development that is being done all over the country, or also we can say all over the world, we need to understand the impact of carbonization. So and need to work on the decarbonization. So most of this we have to work on the reducing or like recycling the construction and demolition waste. So with that, we'll be definitely able to reduce the carbonization impact, uh, and then there should be at every place there should be safe streets and accessible public toilets. So these are the few things that we should be kept in mind. And when we are thinking about sustainable cities and smart cities, so as we said, there will be data driven and climate resilient future cities. So there are new things like uh, IoT and GIS. Then real time dashboards are there. Then net zero 2070 target is there, so which aims at reducing this carbon footprint by 2070. Then circular economy is there, which focuses on doing the recycling of the waste. And then there is gender sensitive planning, so it should be inclusive for everyone, and it should have a clean, safe, and healthy environment for everyone that is living in that urban area. The next point we will be discussing is about the role of civil engineers. So about we can say about civil engineers. Civil engineers are uh, currently no longer just builders, but they are system designers, then design influencers, and sustainability champions. So when we are having this responsibility on the civil engineers, so they need to work or look at this situation as not just as a problem, or but as an opportunity, or also as a career path, so that they can work on it or choose it as their career path as well. So when we are talking about undergraduate students, so there are many opportunities to work on urban planning basics. With that, they can start if they, that can go till higher studies as well. There is a huge scope to work or career opportunities are there in GIS and beam modeling, like building information modeling tools are there. Then there can be opportunities in environmental engineering. Then there can be transportation planning that they can work. Like this is the subject that that is being taught in the engineering as well. So like it should we should look at it as an opportunity. And looking at the current situation, there will be a huge potential in this career path that they can choose. Then policy awareness is something that each and every uh, residents or every individual should be aware about the policies that are being implemented. So this is something that is uh, decided by doing a deep study by the experts. And then that has a huge impact and will be it will be impactful and useful when being implemented. So we need to be aware about the policies, understand what is the policy is all about, what needs to be done, and about active part with active participation only these policies will be uh, effective. Then uh, then we can look at the civil engineers as urban planners. So they can choose their path as designers in the systems, or they can be this in the decisive teams as well. Also they can work on the sustainability planners as well. So just now as we discussed, so when a sustainability designer is uh, doing any planning, so someone will keep all these parameters or points in mind, and with that there will be definitely effective planning when doing a development or plan for a upcoming or urban development. As we just discussed, so there can be career paths for uh, urban planners, then transport engineer, then environmental and sustainability consultation can be done, then smart city specialist, as just we discussed. So there is a policy by government to develop more than 4,000, maybe 400 or 4,000 smart cities needs will be developed by the government. So that is the target. So in that there is a huge potential to choose as a career path. Then there are, so all these policies or planning are, or the development plan is being developed by the government. So all these skills are definitely needed at government level as well. So there also will be opportunities for the students to choose as a career path that they can choose. And there are some higher study certifications as well. So there is a master's study that can be done in urban planning. There are few certifications like someone who's into civil engineering or any construction activity will understand this certification. So with this, like, the government is also encouraging that the people to have recycle or to use like environment friendly materials and to obtain this certification. So with this, like, there will be subsidies or discounts that will be offered to the organizations or individual doing the developments. So this also people need to understand and take advantage of that. Like, it will not just be like useful from your end, but will also prove helpful for the environment, and like both ways it will be win-win situation. So that also should be taken into consideration. Then there are GIS certifications that can be done. Also, there are transport planning courses. So these are the few points that I have mentioned about uh, career path that they can the students can choose, or also some people who are interested in doing like mastering or understanding the topic in more advanced, so they can do like higher studies or deep dive into the topic to understand more about this. Uh, yeah, so like speaking about the policies that we discussed about smart city mission. So in that, like the mission was launched by government in 2015, and the objective was to like the same sustainability point was there in mind. So they had this objective of improving the quality of life and economic competitiveness and sustainability. So they focused on like area-based development plus pan-India solution. So it was not for just big cities, but also like it should be, it will be well like distributed all over the city, all over the country, and it will not just have technology, but will have good better governance. Also have will have better service delivery. So when they said like when we discuss about the key components of this mission, so they focused on area-based development and then pan-India, pan-city solutions. So in that, like, there will be smart traffic management, then there will be intelligent water supply systems, and smart street lighting will be there. Then solid waste monitoring will be there. Apart from that, there will be greenfield development whenever required, and redevelopment of old zones. These are the things. Then there was a concept about integrated command and control center, so which is called as ICCC. So which will be treated or considered as a brain of a smart city, which will have centralized monitoring of traffic, water supply, power, CCTV, and emergency response system. So which will enable like real time decision making and will help in disaster and emergency management. Like most of us, we have like seen this in like any movies or any news that there are a few systems that are being installed or are available in some of the metro cities as well. It is available that centralized monitoring system is there. So it should be made available to most of the cities, most of the at least the major cities which are like having this urban development and like many people are living there. So there can be any situation that will need some system, centralized system that will enable the decision makers to have like real time decision making and will help in like managing the disaster. So with that, like they had focus on promoting the green buildings and open spaces, also having the rooftop solar and energy efficiency like smart water, like waste segregation and processing. Then as we discussed, like NMT, non-motorized transport, and public transport integration. So, like currently, when we see at the smart cities, so there are few we can list as Pune. So, Pune has smart traffic signals and public transport integration is there. Then Indore has smart waste management and like cleanliness ranking they are achieving. Then Surat has this flood management using real-time data, and Bhopal has smart roads and public spaces. So these are the few examples that we can see, but like most of the cities should focus on like implementing many of these successful ideas and also new ideas to have the complete advantage of this and to have to make the place more livable and healthy. So as as we were just discussing about role of civil engineer in smart cities. So with like doing this higher studies and choosing it as a career path, civil engineers can work on planning and designing the smart infrastructure. They can work on integrating technology with physical systems, then ensuring sustainability and life cycle efficiency. And they can like coordinate with planners, IT team, and administrators. So these are the things that they can do. So we can like understand from this particular mission that it is not just an end. Like we with the like with time we have to keep developing and implementing more and more sustainable ideas and technologies that will help, that will make the city more livable, but also will be sustainable for the upcoming generations as well. So, so it obviously and always depends on doing the planning, execution, and people-centric design. So with this, I have covered like all the points related to sustainable planning. And when we are doing the sustainable planning, we focus on saying that the cities that you plan today will be lived in for the upcoming next 100 years. So that should always be the idea behind it, or the point should be always in mind when doing this sustainable planning. So it is not just a temporary development that we are doing. It will not be 5 to 10 years, but will be there for 100 years, or we can say for generations. It will be used. So that should always be kept in mind. And with that, we like I have concluded my points on sustainable development. So with after this, we can start with the questions that anyone may have. Anybody?
Yes,
Anybody
yes,
has any
yes,
question?
Rohit. Hello.
Yes. Yeah. Yes, sir.
Yes, yes. Wonderful session. So, from anybody audience, please ask questions. Yes, audience.
Anyone having any questions or they want to see anything or any ideas if anyone has, they can
Yes.
discuss like that can be
Mainly
there.
that researcher or what we say, uh, in the working peoples within planning, designing, and for infrastructure development, they can ask.
Yes.
Hello, sir. Good evening.
Yes,
Hello,
sir.
good evening.
Please, please.
Sir, actually, I had heard about the smart roads.
Yes.
Yeah, yeah.
Smart roads, say, when the vehicles pass on those roads, they will
Hmm.
generate electricity and all.
Electricity. Yes.
Yeah.
Yes.
See, is it sustainable?
Yeah. Yeah. Yes. It is
In the sense,
sustainable.
actually, see, some people were telling it is very too costly and all. Therefore, people are not going for it.
Definitely, like when we are going for new ideas, so it will be like for infrastructure development itself, it will be a costly affair, and from like when the road is being developed, so there will be direct cost that will be there
But,
when we are
sir, do
building
you
the
have any
cost.
idea about what is the return period like?
Return period means
Means return period for the investment cost.
from the government point you are saying.
See, even from the see nowadays the most of the roads are being given as a privatized, no, like they take
Hmm.
tolls and all
Yes, yes.
like that. They can go for them.
Yeah, definitely. Like most of the projects are being developed in like public-private partnership
Yeah, yeah, yeah.
model
Yeah.
itself. So they are definitely go with that. Like with this electricity generation, it will be beneficial for each and everyone. Like when we are having this battery charged uh, with like using our vehicle on a road, there will be definitely use. Like we will save on fuel and we'll be more than happy to pay the toll like when we are getting the returns, but
Yes.
like with that we will need time to have like infrastructure ready for that, like even most of the people are not even ready with electrical vehicles. So
Yes.
with that, yeah, initially the government can take the load of developing the roads, but with people, if we want to have the technology, there will be definitely few new devices that needs to be installed into the vehicle that might add to vehicle cost. So initial level, there might be like extra costs that need to be bared by government as well as the vehicle users, but
Yeah.
then there will be like later on benefits will be there with that.
Means you don't have the idea about return period.
Hmm. Yeah, return I cannot say like particularly about
Okay.
the time that it
Okay.
can take.
Okay. Thank you. Nice, sir.
Yeah,
It
yeah.
was a nice session.
Thank you, sir. And it was a like a very good question that you asked about.
Rohit
So
sir,
these are the few ideas that should be like thought of and should be implemented. Like the green energy is definitely the future, like with this conventional or like environment like harmful fuels or energies that we cannot keep using it. and they are also not sustainable for like generations. There is one question I can see in the chat box about IGBC. So for IGBC, there are actually different ratings that come like silver, platinum, and likewise there are some IGBC consultants are also there. So we need to approach them for understanding the in detail requirement. So with the type of rating that we are choosing, it changes, or the type of material that we should be using and the type of documentation that we need to maintain. So that changes with the type of rating that we want to opt for IGBC. Yes, sir. Like, I guess anybody not have any question, so we can conclude. Kate, sir, can we conclude? I can see like many people joined this session, and I would like to thank each one of you for your valuable time to understand this topic about sustainability, and like your interest is really a appreciable thing, and I do really appreciate you taking your time to understand the topic. And one thing like I would like to definitely mention about the sustainability and effectiveness of any new technology or mission that is being implemented, like uh, our own contribution or our own uh, implementation of that any particular system or mission decides the effectiveness of any mission or new technology that is being implemented. So we should be responsible with that to have a maximum output or effectiveness of any new technology or mission. So we should, I would say, like we all should be like responsible, and we should make every effort against the sustainability successful. Yeah. With that, I conclude my session, and I thank each and every one of you for the valuable time. Thank you so much. And thank you, Bobde sir and Kake sir, for providing me this opportunity to present my thoughts on sustainability. And we look forward to bright future and sustainable
Yes.
technologies being implemented.
Thank you, Rohit
Yes.
sir.
Yes. Yes.
Thank you. Thank
Rohit,
you very much. Yes, sir.
Rohit, wonderful session delivering you that very much interested topic you delivered today, and much helpful in future and further, like what we say, in further without planning, we did not go or did not achieve some recent development. So
Yes,
thank
sir.
you very much for a wonderful session. All the participants are requested. I just uh, sending the link in chat box. Please, yes, please video on and give your feedback also. Just a minute. Yes. Please fill the feedback. I think all of you getting the link of feedback and fill immediately. Next session will start within 10 minutes, sorry, 5 minutes. So before you can submit the link. All the participants, please on your video. Yes, and submit your link. Yes, hello everyone. Hello, Ghosh sir. Hello, Ghosh sir. Okay, please complete your feedback. Next session will start within 5 minutes. Okay, thank you. Thank you. Hmm. Yes, hello. Next session will start within 5 minutes. So first session is over.
Nikhil sir, may I audible?
Yeah, hi, sir. Yes, you're
Good
all.
evening.
Good evening, sir. Good evening.
Good evening. Second session start now. Engineer Nikhil Kamble sir, Senior Sustainability Manager, Solistic, Ireland, Europe. Nikhil sir is a sustainability professional with over a decade of extensive experience in sustainability, environmental engineering, and civil engineering. He currently serves as a senior sustainability manager at Solistic, Ireland, where he leads strategic sustainability issue focus on environmental performance, life cycle assessment, and energy efficiency. He is also founder and CEO of ECS Environmental and Civil Engineering Solutions, a startup committed to providing initiative and sustainability solutions for environmental and infrastructure challenges. His technical experts include the life cycle assessment, environmental product declarations, green building on environmental references, and green environment and energy audits. With a strong civil engineering foundations, he effectively integrates sustainability principles into engineering design, construction, and operation practices. With more than 10 years of professional experience, also he has contributed to diverse projects supporting organizations reducing environmental impacts and aligning with the international sustainability standards. Today's topic for Nikhil sir, also we have to life cycle assessment of sustainable infrastructure. Nikhil sir, over to you.
Yes. Thank you so much, sir, for the lovely introduction. And first of all, I would like to thank College of Engineering Malegaon for giving me an opportunity to speak on this topic. As we are living in the world where sustainability really, really matters. I'll just share my screen. I hope this is visible.
Yes, sir.
Is it visible?
Yes, sir. Yes.
Yeah. Yes. Thank you, sir. Yeah.
Yes.
So, first of all, good evening, everyone. And I'll be talking on life cycle assessment for sustainable infrastructure. Uh, First of all, we all know that more than 55% of the world's population are living in cities rather than villages or rural areas. And this number is more expected to rise about nearly 70% by the end of 2050. We all know that city provides much more developed opportunities, much more exciting ways of entertainment and all greater standard of living, so that and of course more job opportunities or income opportunities. That's why people are moving from villages to cities, and hence the expected ratio of converting or increasing the population of cities by 2050 is nearly uh, expected to be growing more than 30%. While our cities continue to expand, we also require more sort of infrastructure to fit the population that has been migrated from villages to cities. And since we will be increasing the infrastructure, this infrastructure will support, uh, we can say that it will support and it will increasingly expose the climate risks, social inequalities, and also it will lead to resource scarcity. And this raises a very critical question, as we are just building infrastructure or are we building resilience? So in this session, we will be focusing on how we can convert our regular buildings to sustainable infrastructures, or how we can look forward to the concept of sustainable infrastructure by the means of the concept of life cycle assessment. First of all, life cycle assessment stands with a very strong backbone whenever the word sustainability comes in the market. Whenever we need to look after sustainability, the first concept which arrives is the life cycle assessment. So in this presentation, we will be dealing with life cycle assessment. The second, which we will be dealing with why life cycle assessment matters in infrastructure. Then we will be talking about sustainable infrastructure, and at last, we will be closing this with a case study. We all were taught, when we were small, we all were taught that there are three basic needs of a human being. That is the food, clothing, and shelter. And as the human has evolved, our basic needs have also been evolved. Traditionally, basic needs were just limited to food, clothing, and shelter, which was sufficient for survival of the earlier societies. And however, in today's what we can say a rapid change world, these needs have expanded beyond mere survival, which include aspects that ensure quality of life, dignity, and well-being. And hence, the new point of view or the new care has been included in our basic need, that is the healthcare. So we have shifted from this food, clothing, shelter to food, clothing, shelter, and healthcare. And this transition reflects a shift from survival based approach to a sustainable and human development approach. Why this change has become, or rather, we would say we would complement it as a development. Why this development has occurred? This has occurred due to the environmental degradation and climate change. We all are facing a very common term which is surrounding around us during last few decades is the climate change. The temperature of earth is rising, the polar ice is melting. This is due to the increase in temperature of earth surrounding, and we all link it to the process of climate change. The development also took place because of the modern lifestyle, the evolution of society and quality of life, understanding the disease and medicine well, the psychological need, the human psychological need, and also the social changes rather than we can say the fancy changes. These all developments have lead to change from the three basic survival things to the four basic survival things, which has included the health approach in it. So this health approach is very important to be assessed. And as I said, there will be shift of population from villages to the cities. There will be huge demand and huge construction of the infrastructures. This infrastructure contributes about 3% to the global. And if you consider just India, then it contributes about 43% in the overall India's footprint, the construction process. And if these constructions are taking place in more numbers, then definitely this number is going to hike by such a sudden manner that it will be crossing about 50 to 55%. Hence, there needs to be controlled some sort of measures, or rather than we could take some sort of small steps that will change our regular infrastructure to a sustainable infrastructure. And to assess this sustainable infrastructure or a regular infrastructure, we need to apply a very sustainable and a systematic approach. And this approach is called as the life cycle assessment. So what does the ISO 14040 says? ISO 14040 says that life cycle is compilation and evolution of the inputs and outputs and the potential environment impact of a product or a system throughout its life cycle. In basic terms, what does the ISO says, or what does the life cycle assessment means? It means evaluation of a material, evaluation of a process, evaluation of a product right from its birth to its death. Means suppose if you are using a product, until that product is brought in manufacturing phase, or rather than we can say until that product is been born till its death phase, what the product has contributed to the environment, how much carbon the product has emitted into the environment, quantifying that carbon is known as the life cycle assessment. And the purpose of the life cycle assessment is very clear. The purpose of life cycle assessment study is to assess the environmental impact of a potential product substitution, the choice of one product instead of other. We are familiar with very fancy ads or very fancy generally clothing or products saying that our product is sustainable. How did they quantify that their product is sustainable? By doing its life cycle assessment. And people tend to use these fancy words in their advertisement that deals to more marketing purpose. Hence, whenever the use of that potential product comes, people try to say, tend to sustainable means, that is the choice of one product instead of other. If you will use a sustainable product, you will be emitting less to the environment. That's why the life cycle assessment is very important to assess the impacts of the product. So in the life cycle assessment, uh, everything, whatever the products are there, whatever systems you will be assessing, whatever the materials you will be assessing, everything comes under a sort of a phase of a production. As we all know that everything in the nature or everything which we are using comes from the natural environment, that is from our mother earth. We extract various metals, various sort of fuels, various sorts of usable materials from the mother earth, and this process generally is called as the process of extraction, that is the raw material extraction phase. During this raw material extraction phase, various equipments can be used to extract the materials, such as mining would require digging, blasting, for extracting of iron, gold, and many other metals. Then that metals will be processed, converted into various products, and will be used by us. Hence, we just need to remember one thing, that everything we use, everything has a base of the natural environment, that is of our mother earth. And extracting the products from the mother earth is the process is known as the process of the raw material extraction. So once you have extracted the raw material, definitely you need to process that material. Once you have processed material, you can make different sort of components manufacturing from it. And basically this is called as the industrial phase. Whenever the raw material extracted from the mother earth, we will do some sort of basic material processing on it. We will try to bring it into small chunks, or rather break it from its virgin form to any another form, and we will send it to the manufacturing process, where various sort of components will be manufactured. Once the component is manufactured, it will be assembled and packed, and it will be prepared into a fine finished product. So this ends the industrial part. The first part was the raw material extraction process, where you will be extracting the products from the mother earth. And then there will be an industry phase, where the impacts, or rather than the material will be tend to various sort of processes in the industry. And once that finished product is ready, the material will be packed and assembled in a good way, and it will be sent to the distribution and purchase part. From the factory, the finished product will be sent to various centers, various parts of the world, that will be leading to the distribution phase, and it will be purchased by various persons or various humans, because what is the sole aim of that material or the product? To serve the human being. Hence, this completes the distribution and purchase phase of that specific product. Then comes the use phase. Whenever people buy something, they buy it for using it or for a specific purpose. And from this phase, the installation and use phase of that specific material start. Of course, there will be some sort of life of that material, during which that material will be used, it will be installed. And of course, if the material requires upgrading and maintenance, it will be maintained and upgraded in a very well manner. And the emissions are also released during this phase. Once the use of that product is over, or the life of that product is over, then comes the end of life of the process. What exactly means the end of life? That the use of that product is over. Now that product needs to be discarded. There is no further any use available. Then what will happen to that product? That product will go through a process of incineration, landfilling, reusing, recycling, or the component reusing. Means the people will discard that product, and if that product is reusable again, then various sort of processes will be done on that. This all comes under the end of life of that product. Basically, whenever we consider end of life of a product, then there are three approaches which are used in the market trends. The first one is the material recycling. What is material recycling? Suppose I am using a product. The product is my mobile phone or the laptop or the computers which you are sitting in front. My age of my laptop is old. It has done all its use, and now I'm going to throw that laptop. Once I throw the laptop, it goes to the waste purpose. What will be done? The material recycling will be done. So what exactly is material recycling? All the parts or the metals or the whatever materials which are recovered from it will be directly recycled from the laptop, and it will be processed, and it will be sent to the processing part. So you can look at the figure in front of you. This is the material recycling approach, and whenever we do material recycling approach, we are reducing the burden on the mother earth. And since we are using the material recycling approach, we are taking material from one product and we are reusing or recycling that material in another product. We will be directly skipping the process of raw material extraction. Hence, once the material recycling is done, the process will directly start from the manufacturing phase, that is the industrial phase, and then again that material will be distributed, installed, used. The second sort of approach uh, is known as the component reuse approach. Again, take the example of that laptop. Uh, my laptop is discarded. I'll remove the screen from it. I'll remove the keypad from it. I'll remove the motherboards and all the other chips. And directly I will paste that things in any other laptop. So this is known as the component reuse. And by doing the component reuse, I will be directly skipping the processes of raw material extraction and the manufacturing phase. Because I am directly reusing the components, I do not need any sort of industrial processes on that. The third approach is the product reuse. I have discarded a laptop, but that laptop is in good condition. I'll give it to my friend. He will directly reuse that product or the laptop. So by this approach is called as the product reuse approach. By doing the product reuse approach, I will be bypassing the raw material extraction, the manufacturing and assembly. Directly that laptop by logistic or by distribution will go to my friend, and he will start using the life cycle again of that laptop. So this is called the phase of any product, where everything starts from the mother earth and the natural environment, where you will extract all the process or the products from the mother earth, which is called as raw material extraction phase. After that, you will do some sort of industrial work on that product or the extracted raw material, and you will convert that raw material into some sort of components, which is called as the industrial phase. And then you will assemble and pack that product and send to the distribution, which is called as the logistic phase. After that, that product will be purchased by humans, and it will be used, it will be installed and maintained well, which is called as the use phase of the product. And once the end of life or the life of the product ends, the product will be going to its end of life phase, which is called as the end of life, where various processes such as incineration, landfill, reuse, recycling will be applied to it. I hope this is clear, because this stands as the basics for doing any study in the life cycle assessment. If you have any doubts, then please let me know. Any questions? Are there any questions?
No, sir. Good to go.
Yes, thank you so much. Thank you so much. Now let's move forward. So, as we talked about the process, now we will talk about the basic system boundary. So what is a system boundary in an life cycle assessment process? Just we looked after the process, we got to know that there are some sort of inputs and outputs for developing any sort of a product. And when there are various process on that products, they act all under an system. For example, we will again take an example of laptop or the computer which is present in front of you. For the computer, I require glass, I require some sort of metal for its body, I require plastic for its keypad and all the things. So that plastic, metal and the glass, everything will be extracted from nature. Plastic will be made by some sort of other virgin materials also. And those all raw materials will be manufactured in the factory. Then the laptop is ready. That laptop will be going to use phase. So for example, people like us will use that. We will maintain it well, and if we are going to replace it, then we will send that laptop to reuse to some other person. And if that laptop is the life of the laptop is over, then we will send it to recycle or the waste management. So this acts as a typical system boundary for any of the product for which you need to do the life cycle assessment. And during this life cycle assessment, what we did, we took some of the inputs from the nature in the form of raw materials. And during the manufacturing phase, definitely there will be inputs in the form of energy, water. And since we are taking something into system, definitely there will be some sort of outputs from the system. And those outputs can be in the form of atmospherical emissions, waterborne waste, solid waste, co-products, and other releases. So atmospheric emissions that uh, in the sense that since we will be doing industrial manufacturing, there will be emissions of many gases. Those will lead to atmospheric emissions. Industry also release some sort of wastewater that that will be related to waterborne waste. Of course, there will be solid waste due to the packaging or removing of the packaging and other manufacturing process. Definitely, there will be co-products also. If you are producing glass, which is required for your laptop screen, there will be co-products in the form of sand and other releases. Other releases can be in any form or any other industrial waste. So this is what we called a typical system boundary while considering the process of life cycle assessment, where all this processing is considered along with the inputs and the outputs, and assessment of all these inputs outputs along with the system boundary for a specific product. This process is known as the life cycle assessment of that product. Now let's move forward to the life cycle assessment framework. This life cycle assessment framework is given by ISO 14040. There are two basic codes which are used while doing life cycle assessment. The first one is ISO 14040 and the second one is ISO 14044. ISO 14040 provides the goal and scope definition and inventory analysis impact guidelines for your assessment. And ISO 14044 provides you the guidelines regarding impact assessment and interpretation. But this framework, which is present in front of you, is given by the ISO 14040 because this is the base for all LCA studies. So what does this framework say? Basically, this framework is divided into 4 steps. The first one is goal and scope definition. The second one is inventory analysis. The third one is impact assessment. And the fourth one is interpretation. So let's start from the first. The first one is goal and scope definition. So what exactly is goal and scope definition? Here you need to set the goal of a study. I'll just skip back. Uh, the goal of the study and the scope of the study. I'll be discussing this in the detail in the upcoming slides. Basically, goal and scope definition means setting the aim, that why you want to do the life cycle assessment of that product. What is your exact purpose for doing the life cycle assessment is all decided in the goal. And in the scope definition, the scope of work is decided. For example, what will be my limitations, how long I have to extend the study, where I have to stop, what system boundaries I will be using, what functional unit I will be using. These words are very new to you, the system boundary, functional unit. I will be explaining these words in the upcoming slides. The second step is the inventory analysis. Once I know what is my aim for that product's assessment, I'll be doing inventory analysis. Inventory analysis basically means data collection. The simple word for inventory analysis is data collection, and this is the most critical step while doing any life cycle assessment project, because it contributes about 80% of your time in the LCA project, where you have to collect all the data related to these system boundaries. Suppose you are assessing your laptop, you need to collect all sort of raw materials which are used in laptop. You need to know all the manufacturing process for that laptop production. You need to know what sort of energy is used, what is the amount of energy used, what is the amount of water which was used in this laptop production, what are the amount of metals, glass, exactly you need all the quantities. And of course you also need to know the outputs, because as I said, whenever there are inputs in a system, definitely there will be some sort of outputs. Hence, collection of these data, the inputs and outputs, everything comes under the scope of inventory analysis. Now I have my goal decided, I have collected the data, means my inventory is complete. And after that inventory, what I will be doing? I will be doing the third step, which is impact assessment. Means I will be extracting the results of that collected inventory. So what does exactly impact assessment means? To take out the results or to assess the impacts for the collected inventory based on the goal and scope which we have decided. Impact assessment is basically known as assessing or giving the inventory to any sort of software, any sort of manual tool, any sort of emission factors, and taking out the results. So once this impact assessment has been done, then we go to the last step, which is called as the interpretation of the results. Interpretation in sense, what does the interpretation of result means? Means exposing the results to the environment. What does this means? That you have decided the goal and scope. Based on that goal and scope, you have taken out the inventory. Based on the inventory, you did the assessment and you got some sort of result, and exposing or publishing those results in a specific format which is given by ISO is called as the interpretation. And of course, interpretation includes two main steps in it. The first is result expression, and the second one is hotspot analysis. Hotspot analysis in sense, what exactly are your hotspot in that life cycle assessment? Means what exactly is contributing more, what exactly is contributing less, what is contributing negligible. So all these things are explained in the interpretation parts. Basically, the results from the impact assessment are detailed, or we can say are explained in the part of interpretation. So these completes the four steps. But what are the applications for this? Product development and improvement. Whenever I do LCA for an laptop, the example which we took, if I'm doing LCA for an laptop, if the impacts of the LCA are high by using the metals, then I can replace the metal with some sort of other alloys which are having low impacts. Hence, this leads to product development and improvement. The companies also can do strategic planning. What does exactly strategic planning means? Means they need to, since I told you that they will be replacing the metal with an alloy, they need to plan it very strategically that the cost of the laptop also doesn't increase, but the durability remains the same, but the product becomes sustainable. So this helps also in the strategic planning. The next is public policy making and marketing. Of course, marketing, LCA will also help marketing. That suppose the laptop which we have said is having a footprint very negligible, then people can market, the companies can market it as, since it is a very sustainable laptop, you can use it, your carbon footprint will be low. Some fancy stunts will be played based on the name of sustainability by the companies by doing the LCA, which can help in the marketing and more sale of the product. Now we will look everything in detail. So what does exactly the goal and scope definition means? I hope this is clear till here. Everything is clear. If you have any doubts, please let me know. Any doubts till here, till LCA framework? Okay, we will go forward. Now, we will look in the detail what does exactly the goal and scope definition means. So first, the goal of the LCA. Whenever you are doing a project, you need to set a goal of that project. You need to know why exactly I'm doing that project. For this whole presentation, we will keep the laptop case study as common for the theory part. Then after we will discuss about the infrastructure part. Now I'm going to assess my laptop for its life cycle assessment. So I'm setting goal for it. What will be my goal of this LCA? First of all, I need to know the aim and objective of the study. What is my aim and objective? The aim and objective while doing the LCA of the laptop, I need to know the intended use of the results. That is the application. I'm going to do this LCA of the laptop, but what is the use of the results that I'm going to get? Whether I'm going to do the marketing for that, whether I'm going to tell that company that your product is not sustainable, or I want to find that how harmful a laptop use can be. So exactly during the goal of the LCA setting, the intended use of the result or the application is also decided. After that, the initiator and the commissioner of the study. These two terms are very important because the initiator is the person who initiates the study, and the commissioner is the person who executes the LCA. The initiator can be the management persons of the that manufacturing company, but the commissioner would be definitely the environmental expert who will be carrying out this LCA. All these things are decided while doing the goal of the study. Next, the practitioner of the study. Practitioner means who is going to execute the data collection process, the modeling part, or the result extraction part. Next, the stakeholders of the studies means the intended party who are going to initiate the study. And the last, the intended users of the study means the target audience. I'll be telling that my laptop is sustainable, then my target audience will be educational institute, big IT firms who deal with CSR sustainabilities. These all things need to be decided before starting any LCA study in the process of goal definition. And once we have decided, hello, any doubts? Okay. Once the goal of the study has been decided, we will be switching our target to the scope definition. So what exactly the scope of LCA it has? First of all, it has temporal coverage, average, specific or average data. Since we will be dealing with large scope of work, we need to be very specific about the data. This concept is called as temporal coverage, where you will be dealing with specific or average data. Then the technology covered. Laptop manufacturing can have much micro technology and macro technology also in it. So we need to decide that whether we will be covering that technology or not. Coverage of economic process. Basically, as I told you, material replacement can deal to various economies. These also needs to be decided in the scope whether you need to consider that or not. Coverage of environmental interventions and impacts. Which impacts you will be dealing with. For example, if I just want to know the carbon footprint of that laptop, then I will be only dealing with the global warming potential. But I want to know about the carcinogenic, whether the laptop production is carcinogenic for human, cancer causing or not. Then I will be also dealing with human carcinogenic and human non-carcinogenic impacts. So these all things need to be decided in the scope. The next is the mode of analysis, that is the attributional versus consequential LCS. Basically, attributional and consequential LCS are the two types of LCS. Uh, Attributional means the full LCS study where you will be covering all the processes, and consequential LCS study is the study where you will be only looking at the change in the processes. So, and the last is the level of assessment. Level of assessment means how deep you want to study. You want to just consider the factory data, or you want to cover all the factory data, the literature data, the environmental surveillance data. All the things are defined in this scope. Now, once the goal and scope of the study is defined, definitely we will be moving to the second step, that is the inventory analysis, which is typically known as data collection. But before that, as I told you about two terms, the functional unit and system boundaries, we will be talking about that. The functional unit is very, very important for doing any LCA study, as it acts as the base for data collection process. So what is a functional unit? A functional unit describes the primary function fulfilled by a product system, and it indicates how much of the function is to be considered in the intended LCA study. Rather than understanding in this definition, I'll directly give you an example. Now, since we are talking about LCF laptop, what is going to be my functional unit? My functional unit is one piece of laptop manufactured. Means I will be assessing the impact for one piece of laptop manufactured. There are much more other examples that I have given in the on screen. You can, if you are doing LCA of electricity, then what is going to be your functional unit? Suppose that electricity is produced from coal, oil or wind, then amount of energy, 1 megajoule or 1 kilowatt hours of energy produced. This is going to be your functional unit. If you are doing LCA for soft drink packaging, then what will be your functional unit? Liters in particular size. For example, if you are doing LCA for 1 liter bottle, water bottle, or the Bisleri bottle, then what is going to be our functional unit? One liter plastic bottle having a packaging size of 1 liter. This can be your packaging unit. The light bulb, if you're doing LCA for light bulb, then the functional unit can be in the means of years or a specific lux. If you're doing waste management option for discarded cardboard, then you can use the functional unit of kg cardboard. If you're doing it for wallpaper or paint, then area and year. If you're doing it for people transportation, then person and kilometer. And for if you're doing for good transportation, then it can be ton and kilometer. I'll explain good and transportation because this is much more used in every LCA. Suppose your functional unit, you want to do study of 1 kg of metal transported for producing one piece of laptop. Then for that transportation process, 80 tons of metal was imported. Then your functional unit for that good transportation would be 80 tons of material or metal imported for producing one piece of laptop. So what does the functional unit does? It provides you the base for what? For collecting data. Since I am only dealing with one piece of laptop manufactured, I do not need to collect data for 1000 or whatever the production capacity of that plant is there. I'll be dealing with the data for just a single unit, so that the data is very sophisticated and the data numbers are not very huge. Hence, the functional unit provides you an ease in doing the LCA assessment. The next important part in an LCA assessment is called as the system boundaries. We have heard these words, the cradle, the grave, and these all comes in the system boundaries. Just we need to remember two basic terms. The cradle means the birth, the grave means the death, and there are several types of gates. I want you to look after this figure where there are four processes. The first one is raw material acquisition. The second one is manufacturing production process. The third is use and maintenance. And the last is end of life. When my product is studied from cradle to grave, which is a very basic system boundary. Cradle means the birth and the grave means till it death. Then I will be assessing all these four system. Means impacts related to all these four system will be considered in the cradle to grave. If my system boundary is cradle to gate, as you can see, there are two types of gate. The manufacturing process, production process, this is known as factory inlet gate. And this gate, the gate to gate, the second gate, this gate which is starting from the end of manufacturing process, this is called as the factory out gate. So just know the difference between the factory input gate and output gate. If my system boundary is cradle to factory input gate, then I will be dealing with only impacts related to raw material extraction and transportation of that raw material till the factory inlet gate. Only these impacts will be studied. If my system boundary is from gate to grave, then what will be my considerations? I will be taking the finished product. Since this gate starts at the end of manufacturing process, means my manufacturing, packaging and all the things are produced. I'll be only taking the impacts from the finished product, the transportation of that product to the market, the use and maintenance of the product, and the end of life of the product. This is gate to grave. There is one more system boundary which is very trending and new in market, that is called cradle to cradle. Basically, this deals with circular economy. In cradle to cradle, all the systems are considered, but the process of recycling, reuse comes here. So what does exactly cradle to cradle means? When the product's life cycle ends, the product is reused in any another virgin material. As you can see, this arrow is going here back again. Means if once my laptop is degraded or its life is over, I'll be removing the screen and I'll be using that glass for mobile phone manufacturing. Then that becomes the cradle to cradle. So if the products or the some sort of components are reused or recycled from any product, then the cradle to cradle system boundary is used. So this is all about the system boundary in an life cycle assessment study. Let's move forward. There are various levels of system boundary: first order, second order, and third order. So what exactly are this order? The first order deals with only on-site impacts, which is very rarely used because it doesn't make any sense. If you are only taking the impacts from an industry, that is the on-site impacts, doesn't give you a complete understanding about the sustainability of the product. Since the product has much more background, right from the raw material, right from the product extraction to all the other processes. So the on-site impacts are very rarely used. The second order, all processes during the life cycle are included, but the capital goods are left out. So what does second order means? It includes all the phases of the life cycle, right from the raw material extraction, manufacturing, use phase, end of life phase, but only the capital goods are left out. So what do you mean by capital good? Capital goods are the equipments which are used in the industry, which are produced once in a lifetime. Example of an capital good in any industry can be a boiler or other CNC machines. And the next is the third order, where the second order plus capital goods is used. In most of the LCAs nowadays, only the second order system boundaries are used, where the process related impacts are taken, because capital goods cannot be taken into consideration as they are installed in the factory for once in a lifetime. Now you have decided the goal and scope. You know what is the system boundary of your assessment. You have also decided the functional unit. Then you will go for the process of inventory analysis, which is called as the data collection. As I have told you, inventory analysis contributes about 80% of the time in any LCA project. That is the data collection part. And there are two types of methodologies which are used in the inventory analysis. The first one is the foreground data collection and second one is the background data collection. And an LCA study definitely consists these both data collection methods. And LCA cannot be done based on the foreground data only, and LCA cannot be done based on the background data only. Definitely both the systems or both the data collections are required to do a single product LCA. So what exactly is the foreground data collection? In simple language, the data which is collected on the manufacturing site is called as the foreground data. And what is the background data? Background data is the data which you refer from various research articles, literatures, industry magazines. So this data is called as the background data. Foreground data is the data which you take from the manufacturing site, and background data is the data which you take from published paper, literatures, journals, and reference book. So what exactly foreground data collection requires? For foreground data collection, first of all, you need to go on site, you need to look at the production process, and you need to establish a communication channel between you, manager, and the worker so that they are very comfortable in giving data. Then you need to understand specific terminologies and the way data is normally collected. By going on a site and asking some sort of very difficult technical questions doesn't give you a very sweet spot there. If you are going on a site, then you need to go at their level and ask for basic questions and understand specific terminologies that are not theoretically taught to you in the books, but that are used in the industrial processes. Then based on all these things, you need to develop a questionnaire that is understandable and distinguish between company and site data. First of all, the most important thing which you need to remember is that do not ask for background data from sites. You will go to some sort of worker who is working in an industry and you will ask, what journal should I use to do this LCA for this background data? He won't be able to answer you that you use Springer, you use Springer Nature, you use elsewhere. So it is a very foolish thing to ask about background data from sites. The second process is background data collection. Here you can use LCA database. There are many LCA databases such as EcoInvent, ArcGIS. So these databases you can use for the background data, and also there are various literatures available for that product. Hence, if you are using all this background information, then it comes under the background data collection. So these are the two types of data collections which are required for completing the inventory analysis. And so this is the perfect example of the foreground data: material acquisition, manufacturing, usage, disposal, recycle details. You can take all this data from the site. If you go to, we will continue our example of the laptop. I went to the factory of Dell. I will ask them, from where do you take the materials? I'll get the answer. What is your manufacturing process? What sort of energy you require? What sort of water use require? What sort of machine usage is there? Everything I'll get from the on-site. And what sort of waste you generate? Everything I'll get. But once I can't ask them that what is the transport and electricity mix. Matlab, the what is the electricity mix? What is the grid mix? The energy which you are getting at the plant comes from hydroelectric power plant, it comes from nuclear power plant or coal power plant. They can't answer these things. These all things such as the transport and electricity mix, market and supply chain, technological efficiency, and percentage of renewable energy. All these things should be referred from literature. Hence, these two things make you clear about the inventory analysis, basically the data collection process in the LCA. Any doubts still here in the data collection module?
No, sir.
Okay, thank you. Let's move forward. Again, we will go back for a few slides. Now, you have decided your goal and scope, and based on that goal and scope, you have collected all the data for your inventory. Now you will be doing the impact assessment. And what is that impact assessment? Impact assessment is aimed to understand and evaluate the magnitude and significance of the potential environment impact of a product system. This means whatever data you have collected in an inventory analysis, you will be feeding that data to some sort of software and extracting the results. This is called as the impact assessment process. There are two elements while doing the impact assessment. One are the mandatory element and second are the optional element. So what are the mandatory elements? These elements are definitely required. Means define impact categories, category indicators, and characterizational model selection. What does this means? If I am not clear that what is my aim, means I am assessing the laptop, and I want to know the carbon footprint. Then I have a defined impact category, means global warming potential. Since I have defined that those things all in goal and scope, I need to take those. That is the impact. It comes under the mandatory element. The second is the classification, assigning results to impact category, and the third one is characterization, where category indicator results calculation. All these things will be cleared in the result slide when we take the case study. The next are the optional elements. What are the optional elements? First is the normalization. Normalization means assigning all the units to each other. First of all, I'll just ask one basic question to all of you. Can you compare 1 kg of cotton with 1 liter of water? Can we compare water with cotton? 1 liter of water with 1 kg of cotton, 1 liter of water with 1 kg of cotton. Can we compare each other?
No.
No, correct. Because they both are having two different units. Kg and liter makes a huge difference. Hence, the normalization is done. What is normalization? Everything is normalized to percentage. I can compare this 100% cotton with 100% water. Since the percentage unit is same, the impacts of all these both cotton and water can be compared. But this completely comes under the optional element of the results. And the next is the weighting and grouping. Weighting and grouping deals with the software assessment terms where the impacts are assigned to weight. Means a specific since your laptop is heavy, it has more metal in it. The metal in the wetting will go more to metal because it is having the major component. And next one is the grouping. Grouping means grouping all the impact categories together, grouping all the plastic things together, grouping all the metal things together, grouping all the metal or plastic chips together. But these all are the optional elements. uh, these are some of the impact categories which are proposed by UNEP. There are two types of impact categories. First is the midpoint category and second is the endpoint category. You just need to remember two important things. Midpoint category cause environmental problems. Means this can lead to climate change. This can lead to melting of ice. This can lead to acidification, eutrophication, growth of algae on your water bodies. This can cause environmental problems, but the endpoint categories called causes environmental damages which are non-repairable. Environmental problems, climate change can be controlled. Growing algae means acidification, eutrophication, growing algae on your water can be controlled. But the environmental damage on human health, biotic and abiotic natural environment, biotic and abiotic natural resources cannot be controlled. Hence, midpoint categories are the categories which address environmental problems. Endpoint categories are the categories which address environmental damages. And LCA results are divided into these two types of categories. Whenever you do an LCA, you will get all these results which which states you environmental problems and environmental damages. And these are some of the basic categories which are proposed by the UNEP. Now you have completed your LCA assessment, you will be going to the interpretation. That is the last part. It is the phase in which the result of the study and all choice of assumptions made during its course are evaluated in the terms of soundness and robustness. And overall conclusions are drawn and recommendations are made. What does this means? Now you have completed your assessment. You got to know that the carbon footprint of the product is high, the acidification is low, eutrophication is high. You will explain all these results in the report, which is given by the ISO 14040 format, which uh, distinguish between the three different elements. Uh, which covers the identification of significance issues, completeness, sensitivity, and consistency checks, and conclusion, limitations, and recommendations. So what does the ISO says that before writing any report, LCA report, you need to be very sure about your LCI, that is the life cycle inventory, and LCIA, that is the life cycle impact assessment. LCI means life cycle inventory, means the data which you have collected. And next is the LCIA, the software or the methodology or the assessment tool which you have used. Then you need to check about the completeness, sensitivity, and consistency checks. This all is done by doing the uncertainty analysis and sensitivity analysis, which is another part of an LCA. And at last, the report should definitely include conclusion, limitations, and recommendations. Only saying that my laptop is emitting 30 grams of carbons or 30 kg CO2 equivalents of carbon doesn't complete your LCA assignment. there should be conclusions, limitations, and recommendations. What should be the recommendations? As we discussed earlier, replacement of the metal for alloys, which has reduced the emission from 30 kg CO2 equivalent to 22 kg CO2 equivalents. So this makes the study complete. One more thing which I would like to share is that as we were looking in the framework, you can see there are these arrows which are going from goal and scope to interpretation, and interpretation back to goal and scope. You can see the arrows everywhere from 1, 2, 3, 4 again till the direct application. What does this tell? It tells that everything is linked to each other, and you can come back from any process to back process. Suppose goal and scope definition is there. I have decided some sort of goal and scope definition, but during the inventory analysis, that goal and scope is not achieved. I can go back again to goal and scope, and I'll change the goal and scope and come back again and do again the data collection. So what I want to tell that all these processes are interrelated to each other. So this completes the basics of life cycle assessment for you. Now we will move to the next point about the sustainable infrastructure assessment. First of all, for sustainable infrastructure, there are two approaches which are used. First is the energy efficiency and sustainable materials. When will be my infrastructure sustainable? If it is energy efficient and it is constructed by using sustainable materials, then only my infrastructure is sustainable. Uh, conti- if you are using normal construction practices for building a house, you are not going to make the infrastructure sustainable. By making small changes, for example in the energy efficiency, you have installed solar panels and you are not dependent on the grid electricity, definitely it is an sustainable infrastructure because you are energy efficient. If you have used sustainable materials, for example if you have used recycled plastic paving blocks instead of that concrete paving blocks, then definitely you are towards this type of the sustainable infrastructure. Then what is the importance of sustainable infrastructure? First of all, the sustainable infrastructure is very cost efficient because just remember one thing, it is cost efficient in the terms of long-term savings through reduced operation and maintenance cost. I am not saying that it has in a very high, very low construction cost, but you can achieve long-term savings through the sustainable infrastructure. The second is resource management, where optimize resource using by utilizing renewable materials and energy. As I said that if you have replaced grid electricity by solar panel, then resource management happens, and this deals to resource management. The next is the community impact, enhancing local well-being and promote social equality in design. Community impact in sense your building will look different, and definitely it will send a good message in the society. The next one is resilience building, design system that can withstand climate change and natural disasters. By using some sort of sustainable materials, definitely the building will withstand climate change, it will reduce the climate change, and also it can handle natural disasters. The next is reduced emission. Definitely, whenever you are using sustainable materials, sustainable material itself says that it has very low emissions. Your building will emit very less to the environment, and it can promote sustainability. Then, what are the key principles of sustainable design? A very basic principle is that use locally. I am constructing a house. I am bringing my tiles from Gujarat because they are very cheap there. Because Gujarat has more production of tiles. Rather than go to a local shop, negotiate with them, take the material from the local shop. It is called as the local procurement, because transport emission for my house from Gujarat to Maharashtra will be much more, because the amount of diesel will burn, the maintenance of the vehicle, wear and tear of the roads, everything will come. Rather than go to a local shop and take those tiles, which is called local procurement. Next is the optimize energy, incorporate energy efficient system to minimize overall energy consumptions. As I told, solar energy, wind energy. Then next is prioritize durability. uh, of course choose long lasting material to decrease the need of replacement. uh, a simple example in building sustainability for durability is that there are many ceramic companies, but very of them, very less are having nice durability. For example, if I try to take some sort of wash basin from a local, it can break easily due to impacts. But if I take from a very nice company, then which has got a good material, then it can last long. The next is promote diversity. Design landscape that support local flora and fauna for biological balance. If you are staying in Maharashtra, don't try to plant apple trees in your garden because that is not going to support. Try to plant what we can say guava or local things which are growing that will support the flora and fauna, and this will help to make you keep the ecological balance. The next is implement recyclables. Definitely, you can use recyclable materials to reduce waste and environmental impact. The filling is done during the plinth work. The debris of other construction uh, building can be used rather than procuring a fresh murum. This means implementing the recyclables. The last one is the engage stakeholders. Involve community inputs in the design process for better acceptance. Your neighbors, they can also help you to keep to be a sustainable design. Of course, there are many people who are having idea about this, not technically, non-technically, but good suggestions can come definitely. So involve the stakeholders and the community for the sustainable designs. So these are the key principles of the sustainable. And what are the current trends in the sustainable infrastructure is about the certification. The green certification, we all have heard about LEED certification and BREEAM certification, and these are the why these certifications are done for high rise buildings and the constructions which are having huge area, to ensure the environmental friendly practices followed by the builder, and to reduce the footprint. And the next one is circular economy. While explaining the system boundary, I told you about the concept of cradle to cradle, where once the end of life happens, that material is reused again in any another. Means the process of reusing and recycling material in various designs leads to circular economy. So currently there are these two trends for the sustainable infrastructure. I hope this is clear till here.
Yes, sir.
Yes, thank you. We will proceed. Now we will be looking for a case study. Uh, this is the apartment which is in Maharashtra itself, and the specifications of building are, it is an RCC structure, it is a G+4 building, and the age is 6 years. We will be doing a sustainable infrastructure assessment for this building. Okay, I want you to remember the 4 steps. The first one is goal and scope. The second one is inventory. Third one is the assessment, impact assessment, and the last one is interpretation. Okay. So initial study, I'm going to start. I need data. So what are the key requirements of my study? I require plans, and based on that plans, I will prepare an inventory data sheet. Again, everything starts with goal and scope. So what will be my goal? Simple: to assess the environmental performance of the selected RCC building in terms of energy demand and greenhouse gas emissions over their life cycle. This is a very clear goal. What is my goal? I want to know the impacts of that RCC building, which I have selected, in what terms? In terms of energy demand and greenhouse gas emissions. Greenhouse gas emissions means CO2 and any other gases. So this is a very clear scope before starting my LCA study. Of course, my scope, what is the scope? For educational and project purpose assessment. Now, since you have decided the educational goal and scope, I'll be designing the functional unit. As I told you, while we were looking at the case study of laptop, what was our functional unit? One piece of laptop manufactured. For plastic bottle, it was 1 liter of plastic water bottle manufactured. Same in this case, for the building, my functional unit can be 1 meter square of gross building area. It can also be one piece of building constructed. There are different functional unit for a same entity. It completely depends on the LCA assessor who is going to assess. Just take an example of this building itself. I study that 1 meter square of as my functional unit. Any other assessor will use as 1P, means one piece of that whole building. Third assessor can use that the floor area in meter square. Another assessor who is only dealing with concrete in that building can deal as 1 meter cube of concrete use. So there can be many functional unit, but the functional unit should be selected such as which covers all the aspects of that building. Hence, our functional unit is going to be the functional unit is going to be 1 meter square of gross floor area of the building, assessed over a service life of 40 years for cradle to grave. Again, I'm repeating, cradle to grave means birth to death, means this LCA study will cover the raw material extraction process, manufacturing process, transportation process, use phase of that building, and the demolition phase of that building. Since we are dealing with cradle to grave for 40 years, means the use phase of the project or the building is 40 years, and after the 40 years the death of that building, that is the grave system, will start. Again, since we are starting an LCA study, we need to sure what we are going to deal with. Hence, we will also decide the impact assessment, that is the eco-invent database with SEMA-Pro software and recipe assessment methodology will be used. So this clears your goal and scope. Now you are very sure that you need to collect the data only for the functional unit that you have assessed. You don't need to collect all the data for the whole building, because for whole building there might be more than 2000 bags of cement used, more than what we can say, more than 15,000 liters of water should be used. So you don't need to collect that, you just need to collect the data for 1 meter square of gross area. Now goal and scope is decided, we will move to inventory collection. Before that, we will look at the system boundaries for infrastructure assessment. If you are dealing with infrastructure assessment only, we have decided the system boundary to be cradle to grave in our goal and scope definition. So what exactly this cradle to grave will include is displayed here. First is raw material extraction. Second is the construction stage. When you are developing any product, it will be manufacturing phase, because वो सब industry में होता है. Now since you are dealing with the building, there will be construction stage. Next is the use stage of that building, and the last is the end of life stage. So what does exactly the raw material extraction stage will cover? It will cover the extraction process of raw materials from the mother earth, transportation of raw material from that mother earth or the extraction site to manufacturing plant, and third is the manufacturing impact. Then in the construction stage, there will be upstream transport. Upstream transport means from this industry, suppose there is cement industry. From the cement industry, that cement will be bought from that industry to site. Steel will be bought from that industry to site. Bricks will be brought from that plant to the site. This all comes under the upstream transport, and of course the construction process. Then there is use phase of that building. In use phase, the first one is in use. Matlab, the people are living there, they will be using that building, they will be in using phase. The maintenance done by that people, repair done by that people to the building, replacement done, refurbishment done, resource use in term of what? We are living in a house, we require electricity, we require water, we develop solid waste, we develop waste, then generated waste. All these things will be come under the use stage. And once the end of life comes, we decided that we are going to assess it for 40 years. We will be doing it for 40 years, and once the 40 years are completed, the end of life stage will come, where deconstruction, matlab demolition of that building will be done, and the construction and demolition waste will be downstream transport to waste processing treatment. And if something is not to be waste processed, definitely that will go for disposal. For example, during the waste processing, we can separate concrete and steel. Steel will go to the processing plant of recycling, and the concrete and leftover will be go to landfilling, that is the disposal. So this completes a system boundary for an infrastructure assessment for cradle to grave. Now I have collected the data for that specific building. So this is the building which we are assessing. So first is the raw material extraction stage. So you can see we have considered all the raw materials which were used in the building in the form of cement, sand, aggregate, water, steel, paint, plastic, putty, bricks, ceramics. All the raw materials are taken here. And you can see I have taken everything required for 1 meter square. So 272.74 tons was cement was required. All the GI pipes, the stainless steel things, PVC, septic tanks, brass fittings, everything has been taken. So this completes the raw material extracting stage. So what exactly in the raw material extraction stage have we done? We have collected all the raw material required for that building. The next is the upstream transport. Now, what is the upstream transport? The quantity of the raw material comes here. The transportation distance from, suppose cement was coming from a distance of 5.70 kilometer to that site. The supplier is 5.70 kilometers. So we have multiplied the quantity by the distance and we have converted the upstream transport into the ton kilometer since we want to keep a single layer unit. So this completes your upstream transport. And the next one is the construction phase. So what does construction phase includes? Definitely we know that there are fuel mixers, concrete mixers in used while doing the construction. During this building construction for casting of slab beams and columns, a concrete mixer was used and petrol fuel and diesel fuel was used. Hence this fuel has been quantified. The construction water, the potable water which was used during the consumed during the site construction, the electricity and the transportation of worker has been considered, and waste generated during the construction phase. You know that there is huge amount of waste generated. Waste was in the form of waste concrete, bricks, waste tiles and waste reinforcement. So this completes the inventory for construction phase. Now we will look at the inventory, that is the data collection for use phase. In use phase, every tenant was surveyed and electricity bills were analyzed and the data was collected for electricity usage, potable water usage, LPG usage, solid waste generated and the wastewater generated. And all this data is for the lifespan of 40 years because that building is to be used for 40 years. Now, there is an exceptional case of the renovation phase. Not all tenants living in that apartment did renovation because some of them were living by rent, some of them were owners. Those who tend to keep the flat or the house good, they did the renovation. So change in paint was done, a change in sanitary ceramic and change in kitchen sinks were done in that building. And all this data was collected in the renovation phase. Now, the last phase is the demolition phase. For demolition phase, once the 40-year life of the building was done, the building was demolished and this was the waste percentage. But we need to be very specific, as I told, since this is an LCA study, we need to cover all the perspectives. The demolition equipment was used as a 20-ton hydraulic excavator, which uses the fuel of 1.77 liters per meter cube of demolition. And of course, the downstream transport where the debris was taken from the site to the landfilling area, and the waste distribution has also been given. So these complete all the inventory where we covered the demolition, use phase, renovation, construction, upstream and raw material extraction. All these things from cradle to grave inventory we have covered now. Since we have completed the inventory, we will be giving this inputs, the inventory collected, to the software. For this assessment, the CIMAPRO software was used along with EcoInvent database. And the assessment methodology means the method which has assessed these numbers is recipe method. There are much more methods available in the market. In the slot of 8 Jan, we will be discussing all those methods and softwares which are used in the sustainable constructions. So we will be discussing those things in that session. And from this, I got to know that these are the impacts of each of the phase. You can see that the total is 100%. There is no any unit, means these all results are normalized percentage results. Hence, I am easily able to compare the global warming potential with the ozone formation potential. If GWP was taken in kg CO2 equivalent and any other, for example, the terrestrial ecotoxicity was taken in CFC equivalents, then I was not able to compare the impact. Hence, normalization method is used and all these results are given in normalized percentage. Since this is just a case study, just know that the use phase has most contribution because construction phase lasted only 2 years, but the use phase got it is for 40 years. Okay, so these are the CIMAPRO results which we got. And now we will be applying a sustainable approach to this building. What sustainable approach can be applied? We will do a material replacement approach, conventional to modern construction practice approach, operational energy efficiency, design for adaptability and reuse, circular economy and end of life strategies, low impact construction logistics, water efficiency and resource conservation, and indoor environment quality, which is called as indirect sustainability. So these are all the sustainable approach that can be taken during pre-construction and of course the after construction also. So the same sustainability approaches are applied to the building and the impacts are revised. And almost uh, averagely 50% of reduction has been observed in every category just by replacing the materials. What were the materials replaced? The local PPC was replaced by OPC. The lights were replaced by the solar lights. The bricks were replaced by the conventional blocks. So such material replacement was done and there was a 50% reduction in every potential. Now, there was one scenario in this case study where the RCC was converted to CLT, that is the cross-laminated timber. It was assumed that if the same building was reconstructed in timber, then what would be the impact? Averagely, we can see that about again 55 to 60% of reduction was observed. So these are all the simulations. This was not done practically. Hence, these all things are known as scenarios. So this completes the assessment and definitely sustainable construction comes at a cost. There are some sort of limitations. It makes the environment good. It feels nice, but you need to have some sort of limitations in it. First of all, the initial investment is high, very high. Recyclable things seems to be very nice, but they come at a high initial cost because double processes are done. Limited availability of green materials and technology in rural areas, in remote areas, people lack of basic resources. How they will get sustainable resources? So there is limited availability of green materials and technologies. Skill gaps and technical expertise requirement. If you need a green building consultant, hire him. He will charge you about lakhs. So people look after the economy. They try to go to conventional construction. The next is longer payback periods. Yes, it paybacks, but it takes very time. Installing a solar with some sort of government scheme can cost you 1,50,000 for 3 kilowatts. But that 1,50,000, since your electricity bill by using the normal grid was about 1,500 to 2,000, then it can cause you the payback period about 10 to 12 years. So there is a payback, but there are longer payback. The next are the regulations and policy barriers. Yes, you are constructing a green building, you need to have a policy on it. There are some sort of regulatories that you need to follow also. Then perform uncertainty and climate variability. Uncertainty is definitely needed because since you are replacing a natural or sorry a conventional process by something other, you need to be very certain about that thing, that if I am going to replace clay bricks by blocks, then my structure is going to be stable or not. You need to be certain, hence you need to be providing uncertainty and analysis. Then maintenance and monitoring challenges. Definitely some material, green sustainable materials require high maintenance. Social acceptance and behavior resistance. If your building is sustainable but it looks ugly, people will judge you. Then but you need to be ready for all these things. And the last is the land use and space constraint. If you want to develop a nice garden in front of your building and you want to convert your building to green building, you want to apply sprays on the sheets of your windows, water sprays, you need much space for that. And definitely more land will be used. And this can cause you more uh, what we can say, uh, more land is required and more expenses are required. So these are the limitations for the conversion or building a sustainable building. Thank you. If you have any question, then please let me know. I have written a small quote at the last. Let us live gentle on this earth so that the footprints we leave behind become seeds of hope rather than scars of neglect. Sustainable construction is a must, but it should also be economical. One thing very important which I need to tell you guys, that doing a sustainable construction doesn't require special efforts. If you implement small things, such as if you set up a biogas plant at your house, a small scale biogas plant, small scale vermicompost plant, a small scale wastewater treatment system, you install solar panels, you try to minimize the plastic waste, or you send your plastic waste to recycling, definitely you are giving small efforts which can convert your building to a sustainable building. Thank you. Any questions?
Thank you, Nikhil.
Yes, thank you, sir.
Wonderful session. I think there is a life cycle assessment and relevant data is wonderful delivered by you. Also, it is helpful to us researchers, new students, as well as some upcoming student like PG student and maybe faculties.
Yes, sir.
It is that once again thankful to you for giving today's session. So,
Thank you, sir. Thank you.
yes. So anybody from participants, we discuss within 5 minutes and then we close.
Hello.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, good evening, sir.
Good evening.
Sir, session was very good. Though I am from structural engineering background, I understood a lot many things. But I have one doubt. In
Yes, please.
LCA, do we consider reduction assessment, risk assessment? Do we consider risk assessment in
No,
LCA?
ma'am. Risk assessment is not there, but uncertainty analysis is there. Uncertainty analysis is related to data. Whenever you are dealing with huge data, definitely human errors will be there. Risk related to that data collection will be there. Hence, Monte Carlo analysis is used. Uncertainty analysis.
Okay.
Risk assessment is not done because we are not dealing with some sort of structural changes or RCC changes. We are assessing the RCC in life cycle assessment.
But in case of environmental impact analysis, is it considered, I mean, in structural engineering or in concrete, it is not possible. But in case of environmental impact analysis, is it possible to consider the risk assessment in LCA?
Yes, ma'am. The EIA
Yes,
and
EIA.
LCA are completely different field. Environmental impact assessment is to meant for risk assessment. That
Okay.
what are the risks by construction of the building on the periphery of 5 kilometer, 10 kilometers, or what are the risk of setting the industry. Those all things come in the environmental impact assessment. Life cycle assessment and environmental impact assessment two are a completely different world.
Different things.
Yes.
Okay, okay. Thank you, sir. Thank you
Thank you,
very
ma'am.
much.
Okay, yes, anybody?
Any more questions?
Yes, please ask. It is very good platform to think your problems and decide here what is outcome or what is delivered by today and what we will go. Yes.
Sir, one more question.
Yes, please,
Yes,
ma'am.
yes, please, ma'am.
Sir, the case study that you have discussed, is there any paper published on that?
It's in the process of publishing.
Okay, okay.
Yeah.
Thank you.
This material recycles assessment and other parameters are very point of view, in point of view sustainability.
Yes.
Yes, yes. Okay, yes, anybody? So shall we close?
Yes, sir. If there are no
Yes.
any questions, then we can
Okay,
close.
okay. So, okay, once again, thank you, Nikhil. Okay.
Yeah,
And
thank you,
thanks
sir.
to everyone participant. All participants are links are sent in chat box. So kindly please give feedback. Okay. So we will conclude.
Sir, in case of the some difficulty in environmental impact analysis, we may we reach you?
Definitely, ma'am. You can reach us. I'll be sharing my mail ID in the chat itself. You can reach me there.
Yes, sir. Thank you, sir.
Share my mail ID. Just a
Yes,
second.
Nikhil, please share your mail ID in chat box.
Yeah, I'll share. Hmm. Chat box. Yes, I have shared it. Small. If you have any doubts regarding life cycle assessment, environmental impact assessment, then you can reach me on this mail ID. I'll try to answer as possible.
Yes, sir. Thank you, sir.
Yeah, thank you so much.
Yes. So all the participants, please give feedback. Fill up feedback link, which is very important. Okay. Thank you, all participants. Thank you, Nikhil, sir.
Thank you, sir. Thank you. Thank you, all
Okay,
the
okay.
participants.
So today's session is concluded. Next session will be start on tomorrow, that is on 7th January 2026 at 6 p.m. So all should present accordingly. Thank you.